morning, boys and girls. So, watch this. What do you think is happening? This, I used orange juice, poured it into the cup, and then I took 1 tablespoon of baking soda and poured it into the cup. What do you think is happening? Abby?
I got bubbly.
Bubbly, okay. Any more guesses? No? So, Abby is on the right track. So, when I poured the orange juice into the glass, nothing happened. It stayed still. But once I poured the baking soda into the orange juice, we got a reaction. And this reaction is from the orange juice citrus acid that we find in oranges and the baking soda that caused a gas, which released carbon dioxide. As everyone has their Jamboard pulled up, we are going to be adding 2 things to each column. So you're going to need 2 solids, 2 liquids, and 2 gases. So for my example, I am putting ice into the solid column, and then I am putting the water into the liquid column, and then air into the gas column. So I will give you guys 3 minutes to add a text box, a picture if you would like, or a job filling out the columns. We're going to quickly read each one that is in our column. So we're going to start with our solid. We already said ice is a solid. Does anybody know if we take ice and it melts, what does it turn into? Abby?
Water.
Water. So water is a liquid. So also under solid we have desk, rock, pencil, and brick. And those are great examples of what a solid is. For liquid, we have water, coffee, lava, orange juice, and Dr. Pepper. Those are also very good examples. And for gas, we have air, farts, carbon dioxide, hydrogen, and methane as our examples. These are very good examples. Now we're going to learn further about what each a solid, liquid, and gas means so we can understand the concept. So you guys each are going to receive our states of matter foldable that we are going to do together. So basically what you're going to do is you're going to cut on the dotted lines and you're going to have 2 different sections. One is going to be the outside and one is going to be the inside. After you guys have cut out their boxes, they should look like this. So now we are going to be starting. And then at the end, we will have something like this that you will be able to use through the rest of our lesson. So, let's get started. Here on the board, I have the outside and the inside of our foldable. So, if you guys want, you guys can get out your coloring supplies and you can make it color-coded by the states of matter. So we're going to get started. I'll give you a second to get out your coloring supplies if you would like them. So, on the outside, we are going to draw or color in what we think a solid would look like. So, give me some ideas what you think a solid is, what it would look like as molecules. Abby?
Well, like a desk is hard, and there's like a lot to it, so they would be closer together.
Very good. Any other ideas? No? Okay. So, Abby is exactly right. So, in a solid, all the molecules are together. They are not separate or far apart. So, what are outside of our molecules, I prefer to use circles, so I hope you guys use circles as well. You're going to draw circles that are very, very, very close together, representing what a solid looks like. You guys can use your colored pencils. So as you can see, they're all touching. Everything is touching. So you can color them in to represent. I did the color blue for my solid. I'll give you guys a second to do that. Good job. You did more circles. Ooh, very good job. Very close together. Okay, when you are done, make sure your pencil is down and your eyes are on the board so we can move on to our liquid. So, does anyone have any ideas what our liquid molecules can look like? Abby?
Liquid moves a lot, so it can be farther apart.
Moves a lot. I like that.
Water.
I like that term. Where did we use a liquid in the beginning of our class? What liquid did we use? Does anyone remember? Austin? Orange juice. So we could compare that to a solid like the cup. It didn't change its form. A liquid, when I poured it, you could see the molecules. So our liquid can be close together, but like Abby said, they move. So they can go in either direction. So we can have a molecule here, and then we can have a molecule here that goes out. We can have some molecules that are here, and they can go up or in. We can have some other molecules that are just hanging around. We can have this molecule that is bouncing back and forth. And you guys can make your molecules whatever color you would like to, color them in, outline them, whatever is easiest for you. Yes, Abby?
You want the arrows added on our picture?
If you would like, you do not have to. I did not add any arrows to mine. And once you get it done, remember your colored pencil, your markers are down and your eyes are up. And last but not least, we're going to move on to our gas. So what do you think this could look like? Abby?
Like the steam from something hot. So
Okay.
Like moving a lot and really spread out.
Very good. None of our gas molecules will touch each other because they are rising, they're trying to escape. So, basically, you can draw circles all over your paper, but you have to make sure that none of them touch. And then you can color them in any color you want, outline them, whatever you would like to do. So now, I'll give you guys a second to move on. Good. And like how you guys use blue for liquid, because we tend to match water and liquid together, and water is blue. So now we're going to move to the inside of our foldable. So you can now switch over to the other states of matter foldable that you have that is blank. So now we're going to take what we just said, that's all liquid and gas, and we're going to form it into 1 or 2 sentences so that way we have a concrete definition of what these states of matter are. So throw some terms of what we think a solid is at me. You don't have to give me a complete sentence, but just give me some ideas. Abby?
Something that can't change in form.
Something that can't change in form. Anything else? How about the volume? Does the volume change? Yes or no? Austin?
No.
No, okay. So this is a sentence we're going to write on the board. Okay, so now that we have our sentence, you guys should have been following along, writing as well. So now we're going to make, you guys can either put 1 or 2 examples onto your foldable as well. So my example, put EX for short, is going to be a glass. If you would like, you can use some of the examples that we went over on our Jamboard for this morning. So now we're going to move on to our liquid. So what are the terms that we can use in our sentence for our liquid? Austin?
A liquid has molecules that are moving, and whenever they fill the container, they match the volume of it.
Very good. So the big term that I want you guys to know for liquid is moving. Their molecules are always moving. They can bounce into one another, they can shift in either direction. So for our sentence, we're going to be writing a liquid. Now that we have our sentence, we are going to do the same exact thing with our examples. Give me 1 or 2 examples that you can write on your foldable. My example is going to be oil. Like I said before, you can use some of the examples that we put into our Jamboard. Austin, what is your example that you put for liquid?
Orange juice.
Orange juice. Abby, what is your example that you put for liquid?
Coffee.
Coffee. All right, and last but not least, we are going to write our sentence for gas. Can anybody tell me in terminology words that how we can describe gas? Remember, you can use our picture as a reference. Any ideas? Abby?
They are like liquid, they're all over the place.
They're all over the place.
Steam from something hot, like it's gonna be everywhere in the air.
Yes. close, but we're going to elaborate on some of the words that you use. So a gas has molecules that move very, very quickly. So like liquid, they can move very, very slowly. So gases, they tend to go faster. So like that we completed our photo book, we are going to move on to the fun part of science. So you guys are going to be each receiving your science packet today. I'm going to be passing them out. Make sure you put your name on the line that is provided. So now as you guys write your name on the line, I'll give you guys a second to do that. You guys can flip through and see some of the questions that are being asked so you guys can get familiar with what I'm asking you to do today. This part of the class, you are going to be working with a partner. So after I'm done giving you directions, you may get up, find a partner, and find a spot around the room that makes you comfortable, but also out of reach of your other classmates so you guys are not bumping into each other. So for today, our materials are Sprite, ginger ale, and 7-Up. We know these as soda or pop. So once you guys are together and are seated around the room, you're going to go grab these 3 pops, 1 box of raisins, and then 3 of the plastic cups. So you're going to need 3 for each person. So a total of how many cups? 6 cups. And how many cans?
3.
And how many boxes of raisins?
1.
1. So what we're going to do is, I'm going to put these back over there, so I'm not going to open it, but I will quickly explain. Each cup, you're going to write the name of the pop, so you know which cup is what. You're going to open the pop. You're going to pour it into the cup, and then you're going to take about 6 to 7 raisins and drop them in the cup, and we'll see. So, and then you're going to do that for each and every single cup. Understood? Got it. Great. So you guys may get up from your seat, find a partner, and find a spot in the classroom. But once you guys find your seat in the classroom, you guys have to fill out your hypothesis. Once your hypothesis is completed about what you think the pop and the raisins are going to do.
You want to go first?
That's right.
Okay, you're moving up and down. Are yours moving up and down?
No. One, if you look at the top, the others are kind of like sitting on the bottom. I think they're just kind of like stuck together because of the bond.
So guys, as you guys are working on this, are you noticing anything different, cool, exciting? Abby?
Connor's mine is moving up and down.
Up and
It's
down?
moving everywhere.
Are they like dancing?
Yeah, they are like dancing. Yours is just floating at the top.
No, for a second there it was going up and down.
No, it's not.
Yeah, not just like kind of rotating. There it is.
So which one are you guys working on right now?
We're working on the Sprite one.
Sprite. Jim and John started with their 7-Up, and they got some wacky results so far. Ooh, I saw one moving. So as you guys do your other two cups, are there some things that maybe you guys could do?
Oh, we could time to see how long they continue to go up and down for.
Ooh, that's a good one. What else? What else can you do? Abby?
We could see if the raisin gets bigger or smaller.
Ooh. Okay, so we're doing one observation. Okay, ooh. Abby?
We can see if the pop changes color.
Changes color.
So it was a big line, is it right there?
Yours help. Ooh, it's even
Am I gonna bowl up one?
Look at this color.
Ooh.
It looks like the raisins are losing their color too.
What's happening to the raisins over time?
They're slowing down, they're not moving as fast.
Yeah. Okay, I'll let you guys continue working on our other.
Whichever one.
I don't know what you want to try this.
Let's just go over it.
Abby, how many raisins are you putting in there?
I'll put 5 in.
5. And this one is the ginger ale. How many raisins are you putting in, Austin?
I'm also putting in 5.
5.
This is bubbling up a lot more.
So now that you guys have 2 sodas done, you can now observe both of them at the same time.
Are yours moving at all? Because mine kind of looks like at the bottom.
Look at mine moved.
So what's the last pop you guys have to do?
You have to do 7 up.
7 Up. What are your thoughts about 7 Up? What do you think is going to happen?
I said that I think the raisins will move around and that this one will have the most amount of carbonation, having the raisins move around more.
Ooh, I like to use the word carbonation. Do you think 7 Up will have more carbonation? Which one so far, in your opinion, or what you observed out of the Sprite and ginger ale, had more of the raisins moving?
For me, I had more move in the ginger ale. I had 3 out of the 5 raisins move, where in the Sprite, I only had 2 of the 5 raisins move.
Ooh, very good observations, Abby. How about you, Austin? How was your dance and raising?
Mine was the opposite. I had
Opposite.
one move for Sprite and then my ginger ale once I moved.
Not yet. Okay. We'll just keep looking.
It's weird how yours is different than mine, and we use the same.
Yeah. It's still like bubbly too.
Mine's still bubbling, but mine is moving.
What is that
My
bubbling
Sprite
cold?
moving.
And a pop when we hear that. What is that releasing?
Carbon dioxide?
Very good. So right about this time, you guys should be working on your last soda. No rush, but so we're all on the same schedule and observing the same things. It doesn't matter what order the pop you're doing. Just make sure you're doing your last can of pop. Abby, you're gonna put 5 more raisins in?
I am.
5. Austin, how many are you gonna put in?
5.
5. So this group is working on their 7 Up. Austin, if you want, you can move those 2 pop cans so we can see. Thank you.
Miss Connors, none of my raisins are moving at the 7 Up.
Why do you think that's happening? Don't tell me. Jot your answers down. I don't want to hear until the end of our exploration. Austin, were your raisins moving at all?
Not yet.
Not yet. What are some questions you have about it? What are some thoughts or curiosity you guys may be thinking?
My Sprite raisins are still moving, and that was the one that we started with. And my ginger ale ones are just kind of sitting at the bottom now. And my 7-Up ones still haven't moved.
Still haven't moved. I see Sprite. I see Austin and Abby. Your Sprites are still moving.
My 7-Up is changing colors at the bottom.
Changing color.
Yeah, it's more with the yellower.
So do you think 7-Up is absorbing more of the color than any of the other pops?
Maybe.
Maybe. I know ginger ale can be hard to see because it's already yellow. So once you guys are finishing up your observing boxes, you can put side by side each other's cups. So maybe have 7-Up cups next to each other, or 3 and 3, whatever way you want to do. So we can see. I'm going to quickly walk around and see how everyone else is doing. Okay, good, good. So does anyone see a correlation between our orange juice and our baking soda experiment from this morning compared to now? Any thoughts, ideas? Abby?
There was a reaction in the one that we did earlier. The baking soda and the orange juice reacted and like made it like move up the cup.
Yes.
And then with this one, the reaction was the pop and the raisins from the carbon dioxide moving the raisins up and down, and it looked like they were dancing like Venus counters.
Very good. Okay, I'll give you guys 3 to 5 more minutes to finish up. If you have any questions, don't hesitate to ask.
Ms. Connors?
Yes.
Can we try mixing them together and see what happens?
Oh, of course. Let me grab you a cup.
I think we might need more pop.
More pop? Okay. One of each is fine?
I don't know, Austin, how much do we have left?
Do a good amount. So we usually if we all both do 1 cup each.
Well, if you need more pop,
We just need
1 cup?
we'll put all the pops together.
All the pops together. How many raisins did you put in?
We'll stick with 5.
Stick with 5?
Yeah.
Okay. If you want to move those out.
Just pour them all in. We're gonna mix them together. Yeah, we'll see what happens if we mix them all together. Maybe it's interesting. Okay. Let's see what happens.
You guys can watch and take additional notes if you would like. Yes.
Ms. Connors, nothing's happening with our raisins when we mixed all of them together.
Why do you think that is? There's no right or wrong answer.
I don't know, I think the 7-Up just really doesn't want to work, because mine's still not moving when it was just 7-Up.
Yeah. Do you think it could have made a difference if we put an equal amount of all the pops in?
Maybe.
Maybe.
Or less raisins.
Or less raisins? So 7-Up seems to be the one that is failing us today. So as you guys work on the rest of your observation sheets and the last page of your science packet, I'll give you guys a few minutes to do that. And once you guys are doing that, make sure you're tidying up your workstation. I do not want you guys to throw away the pops or the raisins yet, or the cups or the cans. Just set them off to the side so we can move on. As we wrap everything up and you guys are finishing your last final thoughts about the conclusion and other thoughts about the soda you may have, I'll give you 30 more seconds. Wrap your final thought up. Okay, so as you guys are sitting here finishing your thoughts, I'm going to ask you some questions and we're just going to expand your thoughts about what happened. So, what do you think happened once you dropped the raisins into the soda? Any takers? Just throw some ideas out there. Abby?
The texture of a raisin is more of like a rough feeling than like a smooth feeling. So the bubbles from the pop or like the carbon dioxide could like attach to it.
Okay. I like how you said that the raisin was more rough and compacted together. Does anybody remember that word that we talked about? It starts with a D. Austin?
Dense.
Denser, correct. You guys should have been noticing that the raisins were denser than the liquid than in the sodas. So anything else that you happen to notice once you drop the raisins into the soda? You can yell some things out. Go ahead, Abby.
It got really bubbly like when you first dropped them in, and it like
Fizzed.
yeah, it fizzed at the top, and then in some of the cases, the raisins would move to the top and then come back down and move around in the cup.
Okay. Austin, did you notice anything?
When we put the raisins in, some of the sodas reacted differently.
Reacted differently. What happened right when you first dropped the raisins in after that fizz? They
sunk to the bottom.
They sunk to the bottom. Then what started to happen with the raisins and some of the pops that we noticed? The bubbles that Abby said, they started to
attached to the rough surface of the raisin, and then it started to like lift it off the bottom of the cup.
Yes, and what's that word that we can use? It starts with a B.
Is it buoyancy?
Buoyancy, that's what the raisins started to do once the bubbles attached to the raisins. And what do those bubbles contain? Austin?
Carbon dioxide.
Carbon dioxide. So what happened once the raisins reached the top of the surface?
The bubbles popped.
The bubbles popped, causing the raisin to
Sink to the bottom.
sink
again.
back down. And then we noticed that it kept going up and down, causing that buoyancy to rise, to fall, to rise, to fall. So let's rank them. In your opinion, because other groups are different than others, which one had the most buoyancy of the raisins and which one had the least? Abby?
The Sprite had the most. If you look at ours now, it's still moving up and down.
Mm-hmm.
And the one that didn't was the 7-Up. But once we added the baking soda, there's one raisin moving now.
One raisin. What about the ginger ale? What are your thoughts about the ginger ale? Was it decent? Did some of the raisins move?
Yeah, I had more raisins move in ginger ale, but not as long as it did in the Sprite. Like my Sprite ones are still moving, and my ginger ale ones are not.
So the time can play an effect to that. Okay, Austin, do you have any input? I know you guys did it together, but do you notice anything when you poured your pop and dropped your raisins in?
Mine probably took longer than hers did to start rising up, but we kind of had the same thing occur.
Do you think it could have been because she poured the pop first and then you poured it second? Probably. Okay, so how about let's focus on the carbonation level of the pops. Do you think that in every pop has the same carbonation level? If why or why not? Or do you think some pops do vary?
I don't think that they all had the same carbon level. Like the 7-Up probably had the least amount because none of them moved.
Good. Austin, do you have any input?
I think because like they all had different reactions when we put the raisins in, it shows that they have different carbonation levels.
Good observation. So we sort of answered this before, but as you guys can see now, I don't think none of our sodas are, quote, flat, but they did lose some of their carbonation. So in your, I see the 7-Up one moving. So which one do you think went flat first and lost their carbonation the quickest?
Probably the 7-Up because it never moved originally until we added the baking soda, giving it more carbonation.
Good. Which one do you think came in the second?
The ginger ale, because I think a lot of my raisins moved in that one, but it eventually stopped as the carbonation went down. And the Sprite had the most because mine's still moving.
Still moving. So this wraps up today's science class, and I hope you guys enjoy doing everything that we learned today. Don't forget to put your foldables in your science folder, but you may use them as we do our ticket exit for today. So you guys will need to pull out your laptops and log on to our Google form for today. So as you guys do that, on our exit ticket, I'm going to be asking you 5 simple questions. Be sure to answer all of them, and also be sure to put your first and last name on it. So as you guys do our exit ticket, can anybody tell me for today what our solid was in our exploration part? Abby, what were our 2 solids?
Cup and the raisin.
Like our cups and raisins. Okay, what were our liquids? Abby?
Our Sprite, ginger ale, and 7-Up.
Yes, our 3 sodas that we use. And Austin, what was our gas?
Carbon dioxide.
The carbon dioxide. So those 3 are all correct. Now you guys can answer our exit ticket. And once you guys are done with that, put your lab packet and your foldable into your science folder, shut your laptops, and pack up your backpack. And I will see you guys again tomorrow.